Hello, this is Kateri Avila from Chemistry 112. Today I will be showing you and explaining how to draw the VSEPR diagram, the box diagram, and the contour diagram of arsenic pentaiodide. We will be starting with the VSEPR diagram, but to make our lives easier, we're going to actually start with the Lewis structure. So as you can see here on the upper left corner, I've added up the valence electrons available to us to use in our Lewis structure. We start with 5 from the arsenic and 7 from each of the iodines. Since there are 5 of them, I've multiplied that number by 7 by 5, and that gives me a total of 40 valence electrons to use. I've placed the iodines symmetrically about the arsenic, and now I'm going to fill in the rest of the valence electrons that are around the iodines to check and see that my count is correct on my Lewis structure. So starting with the bonds, I have 2, 4, 6, 8, 10 electrons about the central atom, and then I'm going to add 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, plus the 10 that I have about the arsenic. So that gives us a total of 40 valence electrons in our Lewis structure. However, as we've discussed in class, our Lewis structure does not give us the shape of our molecule. So for the shape, we're going to need to do the VSEPR diagram. Thanks to my Lewis structure, however, I know that I have 5 bonded pairs about the central atom, which tells me that our molecular geometry will be trigonal bipyramidal. Here I have placed a triangle to help guide us in making this shape, and I have also placed arsenic in the center and the iodines about the triangle and above and below. And now I will show you how this is arranged. So we have one iodine straight up. This is an axial iodine, and then there's another axial iodine down to the bottom. And then I'm going to move this over just to make sure. There we go. These should be directly above and below the arsenic. And then here we have an iodine towards the back. So to show that, I'm going to put some dashed lines. Here we have an iodine towards the front. To show that, I will put a wedge. And this iodine right here is in plane with the arsenic. So because of repulsion forces, these bonded pairs are repulsing and pushing on each other. So right here, since these 3 are in plane, they want to get away from each other, but they're also trying to get away from the top and the bottom, the axial iodines. So these 3 are pushing away from each other in a plane. So these angles right here, the equatorial angles, are 120 degrees. And this one from the top iodine to this side iodine in plane, this axial iodine to this equatorial iodine right here, is 90 degrees. So this here is an image of my molecule, arsenic pentaiodide, created in Mole's editor. And here on the left, you can see a contour diagram. This shows the atomic orbitals. And then on the right, this shows the atomic orbitals overlap. So again, back to the fact that arsenic has 5 bonded pairs about itself. We have a molecule with an sp3d hybridization. Now moving on to our box diagram, I'm showing you here the ground state of arsenic. So at ground state, arsenic has 1, 2, 3, 4, 5 valence electrons. And we can see that the 4s orbital is full, but the 4p has 1, 2, 3 electrons in it. However, this does not match our 5 bonded pairs. We need to have 5 electrons available for bonding. So to do that, we add energy to our arsenic and we promote an electron to the next level. The next level available will be 4D. Here on the left we have ground state arsenic, and then on the right we have excited state arsenic as denoted by the asterisk. So when we add energy, we'll graduate this electron right here and it'll get moved up to the 4D orbital. So now we have an arsenic ready for hybridization. Now here we have a hybridized sp3d orbital from arsenic. And we have the 5p orbitals from iodine, the 5 iodines. I need one more. And so these electrons form bonds. And these are all sigma bonds. Sigma, 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 sigma. Now here we have the contour diagram. So we'll have the hybrid orbital, the sp3d right here. And we don't have any lone pairs. So these will all have the sigma bonds. With the 2p, well the 5p from the iodine. So here we have the 5p. From the iodine. Overlapping. With the sp3d. So in blue, we have sp3d, and in red, we have 5p. And this is a contour diagram. And I almost forgot one iodine right back here, so I'm going to make sure to get that one, because as I said before, there's no lone pairs. And here again on the right is the computer-generated version. As I stated before, the equatorial angles, so from here to here is 120 degrees, because these iodines are on the same plane. And then from the axial iodine to the equatorial iodine, this is 90 degrees.